Showtime. Why didn't you say it when I got done counting down?
I know.
You could have been on the video.
Yeah.
We're going to do a progression here. So we started by talking about right triangles when we knew two of the sides. We used Pythagorean theorem to find the third side. Then we looked at special triangles when they're 45, 45, 90 or 30, 60, 90. When we're given one side, find the other two sides. So now we get into trigonometry. And trigonometry, question?
I have a question about that.
Oh, wait.
Yeah.
Yeah.
When you do that, if you're given the two sides, can you still use Pythagorean theorem?
For what? This?
No, for what we just did.
For 30, 60, 90?
Yeah.
And 45, 45, 90?
Yeah.
For sure.
Add two sides to use.
As long as you kept your answer in exact form. Okay. Trigonometry will allow us to solve any right triangle, as long as we have some necessary information. Doesn't have to be a 45, 45, 90. Doesn't have to be a 30, 60, 90. You don't have to know two of the sides. We're going to get all kinds of fun possibilities here, so it opens up the window. And then later on in the chapter, we're going to take it even further and solve triangles that aren't right triangles and still be able to solve all the information that we need. So we're going to start with this, how to label a triangle. We already know that the vertices should be labeled with capital letters. In this case, I used A, B, and C. What's new for us is instead of writing the segment AB and the segment BC and the segment AC, we're going to use lowercase letters to represent the length of the sides. Notice that lowercase a is opposite angle A, lowercase b is opposite angle B, and lowercase c is opposite angle C. Not all triangles are going to be labeled this way using those letters, but that system stays in place. Lowercase q is opposite capital Q. Lowercase alpha is opposite uppercase alpha. Okay, we good? Most of the time they'll be given a picture. When you're not, you have to be able to draw the picture and put stuff in the right place. If you put it in the wrong place, everything falls apart. Here we go. Trigonometry. There are 6 trig functions. We're only going to look at 3 of them. They are the following: the sine, the cosine, and the tangent. They are abbreviated sin, cos, and tan. Please don't call them sin, cos, and tan. You just end up sounding silly. Use the full name: sine, cosine, and tangent. The other 3 are not for you yet: cosecant, secant, and cotangent. We're going to take some baby steps first. If you look at your calculator, you will see that there are 3 specific buttons designated for each of the 3 functions. They are smack dab in the middle of the calculator, right above the parentheses and the comma. How many of you never noticed that there's an entire button devoted to nothing but the comma?
Why do we need a comma in math?
I didn't know.
For programming? Syntax? Or they had nothing else to put on the button, so they threw a comma on it. Okay? All right. We're done with the calculators for now. You can put those down. Let's talk about these things. These are functions. They're just like add, subtract, multiply, divide, square root, square. You put a number into the function, it does some magic, and spits out another number. Today we're going to talk about where those numbers come from, how to get those numbers, and how to use them. A function is defined by what it does. Okay, so addition is defined by the fact that you're taking 2 numbers and adding them together. Subtract, et cetera, et cetera. Here's how the trig functions are defined. The sine, cosine, and tangent functions are simply ratios. That's it. Okay, so before you start writing like mad people, give me your attention for a second. Here's my triangle. If I pick angle A, there are 3 sides in relationship to angle A. There's the opposite side, there's the adjacent side, and there's the hypotenuse. The first one that takes precedent is the hypotenuse. This has to be the hypotenuse. No other choices. Therefore, that's an A. A is the opposite side, and B is the adjacent side. So you're saying to yourself, well, hold on, self. If I'm talking about angle A, there's actually 2 sides adjacent to angle A, C or B. But we go with B because C has to be the hypotenuse. It is always the hypotenuse first. If I switch that and talk about angle B, Then I've got the opposite side, which is B. I've got the adjacent side, which is A, and I've got the hypotenuse, which is C. Okay, you with me? C. C. What if I choose angle C? Which side is opposite angle C? C. Which side is the hypotenuse? C. Which one is adjacent? Uh-oh. Could be A or B. We don't like either in math. That doesn't work for us. So how do we solve that problem? We don't. We run away from it because we're afraid of it. So we don't talk about the trig functions when they relate to the 90-degree angle. We avoid it. We'll talk a little bit about it, but not too much. Okay, now that we know that, here's how all of these things are defined. Sine is the length of the opposite leg over the hypotenuse. And so there's a little thingamajobber. I can never remember what this, not an onomatopoeia. What's the... not illiterate. What is that? Mnemonic device. Here it is. So, ka, toa. Sine is opposite over hypotenuse. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So, ka, toa. And again, if you ignore all this mucky muck, you simply get a ratio. That's all it is. All right, let's do this. Here we go. Took this angle. Sorry, that's called a triangle, Reedy. I took this triangle, labeled it APE, and I gave you 3 side lengths, 3, 4, and 5. How do I know that's a right triangle? 2 reasons. There's a right triangle symbol in it. That's number 1. Number 2?
3, 4, 5.
It's a 3, 4, 5 triangle Pythagorean triple. 3 squared plus 4 squared equals 5 squared. Okay. I would like to know what's the sine of angle A. So here's angle A. How is sine defined? Opposite over hypotenuse. So in this case, it would be 4 over 5. Now, this is a real important point, so I don't want to move on until everybody's with me. Is there anybody that's confused or doesn't understand how I got that? Aces. How about the cosine of A? John, say again?
3/5.
Outstanding. Cosine is adjacent over hypotenuse. Tangent of A. Owen.
4/3.
4/3. Sine of P. Now we'll switch. In fact, I'm feeling saucy. I'm going to change colors. Angle P. Oh, hold on. Side note. What's the relationship between angle A and angle P? Ricky, is that a new sweatshirt? That's really nice.
No,
Sure?
I'm sure.
Oh, Brian, did you get your hair cut? It looks really good.
Complimentary.
Correct. They're complimentary. Get it? Noosh. Can I do that? They're complimentary, which means what, Benny?
They both equal 90.
No.
Added.
Added together, they equal 90. Good. All right, what's the sine of angle P? Avery?
3 over 5.
3 over 5. What's the cosine of angle P? Well, 4 over 5. And last but not least, what's the tangent of P, Matt? Opposite over adjacent. Okay? You don't need to know what those numbers are. I mean, you know what a ratio is, but that doesn't do anything for us. That's not very exciting. That doesn't do, I mean, big deal. I get a ratio. So what? But that's where they come from. And you'll see on tests and quizzes when I ask you for the sine of A, you're going to do a lot more work than you need to. you're going to go and find angle A and do all this other stuff. It's just a ratio, that's it. Okay. And then we talked already about this last question here. What happens when you try to take the tangent of angle E? Everything falls apart because we don't know which side is adjacent. Is it 3 or 4? We know which side the opposite side is, that's 5, but we don't know if it's 3 or 4. Pregunta?
But doesn't it like not work from the beginning because it doesn't have an opposite, right?
But it has an opposite side, which also happens to be the hypotenuse. Hold on, we'll come back and play with that later, because it causes all kinds of uncomfortableness, for lack of a better term. Okay, we okay with the ratios now? All right.
Oh, wait. Can we take the tangent of E because it's opposite over here?
No, tangent is opposite over adjacent.
Or the sine, because then it would just be 1. 5 over 5.
Sine of what? 90 is 1
E.
of E.
So it'd be 5 over 5.
Ooh,
Can we do that?
I don't know, can you? What's the cosine of E? I don't know. So you're saying you're only good with the sine? It's 1 out of 3, so 33%. We'll come back to that. All right, let's make sure your calculators are working correctly. So you should see the sine, cosine, and tangent buttons. Just for giggles, type the cosine of 41. If you'd like to, you could close the parentheses, but you don't have to. If you're feeling saucy, just leave it open. Hit enter. What do you get?
Negative point nine eight.
.98733.
Oops.
You don't have it.
I got it.
Oh, your friend pimped you and put you in the wrong mode. Hit the mode button. Are you in radians?
You just got punked.
Wait, what
Yeah.
do you mean?
Oh, I was.
Oh, was that you, Lauren? Did you mess with his calculator?
Wait,
Good job. Air 5 on that one.
Wait, what happened?
I'm gonna
You're in
fail.
the wrong mode. Did you get the same answer as Owen?
Wait, try.
Yeah,
Yeah.
Go to
In
degrees.
mode. Put yourself in degrees.
with mode,
Sorry, Ben, I
There's
did that.
It's the one that says mode on it.
guys. And put in
Yep,
degree.
there it is. Degree.
Everybody else good to go?
No, check.
All right. Try the tangent of 74 then. 3.4874.
Yes,
And the sine of
sir.
2.
Point, oh, yep.
Okay, we're good?
Do we have to change it back?
No, 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 no. No, no, no. Never change it back. Well, not never. In this class, don't change it back. You'll change it back later, but not in this class. While you have the calculator, just for giggles, let's try taking the sine of 90 degrees and see if it melts the calculator. What's the sine of 90? Oh, it's 1!
I did the tangent of 90, it's an error.
You did the tangent of 90 without being told to?
Yeah.
What is wrong with you? That's how accidents happen. What did it say?
Error.
Error?
Error domain.
Domain?
0.
Can't do it.
Cosine of 90 is 0?
Yeah.
Yeah.
Why?
I don't know.
Because if we want to take the cosine of 90, that means we need the adjacent side over the hypotenuse. We don't know which adjacent side to use, but we do know what the hypotenuse is. So we get 0. But tangent gives us, wow, that's very confusing. So again, how do we deal with that? Ignore it, correct. Run away scared. All right, let's do this now. So we are going to start solving triangles. Just like that guy. Notice, that's not a 45, 45, 90. It's not a 30, 60, 90. It's just a plain old right triangle with one angle equal to 40 and a hypotenuse equal to 3 meters. This will be fun.
I'm trying to find x, y.
We're trying to find x and y. So, Peyton, do you want to solve for x or you want to solve for y first?
Let's go for X.
Beautiful, x. Okay, so we know this angle. Stay with me, Peyton. And we know that side. Based on this angle, is the x the opposite, adjacent, or hypotenuse?
Based on that angle,
Yes.
opposite.
Good. And we also know the 3 meters. Is that the adjacent or the hypotenuse?
Hypotenuse.
Good. So what function uses the opposite side and the hypotenuse?
Sin, right? Sine.
Sine. Good, not sin. Sine. Sin, something completely different. Sine.
Sine.
So now we set up an equation. The sine of 40 degrees is equal to x over, whoops, not 30, just 3. Solve that for x.
Let me just put there.
How do I solve that for x? David?
Multiply both sides by 3.
Beautiful. 3 times the sine of 40 equals x. Where does this come from? Calculator. Plug that into your calculator.
We do 3 sine
She rounded.
40.
Hold on, I'll get to rounding in a second. I'll let everybody get an answer. Now, there's a reason why I put the 3 in front. If I put it in the back, that could open up some trouble.
Won't that multiply the 40 by?
Correct. Yeah. You don't want to do this. If you plug this into your calculator, it's going to end up taking the sine of 120. That would be bad. Move the 3 out in front so you get 3 times the sine of 40. And x turns out to be, wait, before you tell me the answer, should x be bigger or smaller than 3?
Smaller.
Good, because 3 is the hypotenuse. And what's the answer?
3.
Our standard will be 2 decimal places.
1.93.
Therefore, 1.93.
3.
Outstanding.
Wait, I said 4.
Mhm.
How the past line?
That's for trig values. This is for angled measures and sides. That's an approximate answer. I don't like approximate answers. I don't want to use approximate answers. So I'm going to find why using more trig stuff, not Pythagorean theorem. Because if I use Pythagorean theorem with that value, I'm going to get an answer that's off. You with me? Changing colors. Okay, still using this angle of 40 degrees. If I know that's the opposite, this is the adjacent side, this is the hypotenuse. What function uses adjacent and hypotenuse?
Cosine.
Cosine. Cosine of 40 is equal to y over 3. So 3 times the cosine of 40 is equal to y. So y is equal to 2.3. 2.3. Okay, so that's the rounding value. Beautiful. When you get done with a triangle like this, you're going to want to get in the habit of going back to the small, medium, large theorem. Remember the small, medium, large theorem? Smallest side opposite the smallest angle, biggest side opposite the biggest angle, medium across from medium. How big is that angle? 50. Does this satisfy the small, medium, large theorem?
Yes.
Yeah. Biggest side is the hypotenuse. Middle side is opposite the middle angle. Small side opposite the middle angle. Okay. We good so far?
Yeah.
Not too bad, right?
Yep.
Good. You're going to need to set up this equation every single time. As you get better at this, you're going to want to skip some steps and maybe even just do it on your calculator. I can't grade your calculator. The reason I want the initial equation set up is so I can check to see which trig function you used and whether or not you set up your ratio correctly. Any questions on this before I erase? Next example. Solve for R and S. Should we do this one together?
No.
You got it?
Yeah.
All right, go ahead. Making progress? See a lot of people getting R and then getting stumped on S. Don't use Pythagorean theorem, use the trig functions. All right, let's start with R. What do you got?
9.71.
Uh-oh. Who got 9.35? Raise your hand. Who got 9.71? Ooh, almost split 50-50. Let's go. All right.
Anyone make a bet?
Ooh. What do you got?
9.71.
Who's got 9.35 and wants to bet? Knucklehead here. Nobody's confident enough in their calculations to bet it?
I'll just bet him.
What, 5 push-ups, 10 push-ups? What do you want to bet?
We'll go 10.
10 push-ups. You in for that?
We're doing it outside of here.
Right here.
Oh, we're doing it right here. I'm gonna have to
I
change
do mine in
it
front of the
up.
class. You're gonna do yours in front of the class, or he's gonna do whichever. I don't know what the right answer is.
We should just go 5.
I'm down.
Keep it light.
5 clappers,
No, not clappers.
5 regular
If I
push-ups.
break my hands on a
you got this
clapper.
on.
Matt, question?
I'm in the bed.
You want to bet too?
Oh, man, let's
I'm
go.
not-
You want to double down?
No, I don't want to double
Okay, just
down.
me and you.
I don't want to double
Just
down.
me and Matt.
Anybody want to take some of Matt's action? What do you got? 7-1 or 3-5?
3-5.
Anybody
I
got
like it,
7-1
Matt.
want to take on Matt?
I'll do 7.
All right. Whoa. Hold on.
And who's that? Jen, you wanna do it, Jen?
No, man, you got it.
You want to do it,
You
or you
go,
want to let
Amanda.
Amanda take him on? Because she can do some. She can do some clappers. She can do the behind the back clap in one hand.
Yes, how often?
Quick, decide. We gotta go.
Okay, I'll do it.
Okay, good. She's on. 5 or 10.
Goodness.
So you two are 5 or 10.
I can do 10.
And no matter
You
what,
good for 10?
I won't be alone.
Good.
so
And you
no,
two?
I'm good with
We're doing
this.
5.
5.
Yeah.
Wow. All right. Here's my angle. I know this side from that angle is the opposite side. I know this one is the adjacent side, not the hypotenuse. The hypotenuse is the one sitting down on the bottom. What function uses opposite and adjacent?
Tangent.
Tangent. Tangent of 15.5 degrees is equal to r over 35.
Oh, this is over.
So 35 times the tangent of 15.5 is equal to r.
Getting swole.
Justin, you're the neutral party here.
You're like Switzerland.
Wow. Pull that out.
9.71.
Get down!
I'll do it.
Not now, we don't have time, not now. We'll do it later. Okay. For those of you that got 9.35, what'd you do wrong?
I
Sign.
Sign.
That'll kill ya.
Okay. Doing S now, we want to stay with the information that we have. We don't want to use R because that's an approximate value. We want to stay with 35 and S. So the 35 we already know is the adjacent side. S is the hypotenuse. What uses adjacent and hypotenuse?
Cosine.
Cosine. Cosine of 15.5 is equal to 35 over S. Uh-oh.
This one I didn't know
Oh,
what
it's
to do.
35 over S, then 9.
How do I solve that?
I'm not sure, but I just multiplied it by s over s because that's equal to 1, so that the s is crossed off, and it's cosine of 50.5 equals 35s.
Nope.
And then divided by. Give it a shot.
Ricky just gave you that.
Okay.
Man,
2 divided by 35.
you could, but that's going to open up a whole new can of worms. I should.
Okay, so I divided. So I had 35 over s equals cosine 15.5, and then I multiplied by s. So I got 35 equals s cosine 15.5, and then so s equals 35 over cosine 15.5.
Okay. Did you follow that?
Yeah.
You don't have to. Here's what you're going to do. Call this the switcheroo. When your variable is on the bottom, in essence what happens is these two things end up switching places. The process that we use to get there is what she just described. But most of you won't remember that. So just remember when the variable's in the bottom, you do the switcheroo. S is equal to 35 divided by the cosine of 15.5. So S equals
35
36.32.
cosine 15. Yep.
okay.
How did you get the 35 on top?
It stayed there. It didn't go anywhere.
No, I mean like.
Oh, when I set it up, because that's the adjacent side, adjacent over hypotenuse.
Okay.
All right, we good so far? So we saw a basic, this is about as basic as it gets. Then it got a little bit more complicated because the hypotenuse was a variable. We good so far?
Mm-hmm.
All right, moving on up. It's a blank screen. What if we want to know the angle though? So I've got that same triangle we had before. It's a 3, 4, 5. I know the 3 lengths. I'd like to know how big angle P is. I know it's not 30 degrees, 60 degrees, or 45 degrees because that would be a completely different setup. This is really easy. And it's all based on a simple concept. We have something called an inverse function. What's an inverse function? What does it do? What's the inverse function of addition? Subtraction. What's the inverse function of multiplication?
Division.
Inverse function of squaring something?
Square
Square root. It undoes the thing that you're doing. It undoes the function that you're working with. So if you look on your calculator, above the sine, cosine, and tangent button, there are inverse functions up there. It says sine to the -1, cosine to the -1, tangent to the -1. That undoes each of the trig functions we've talked about already. Solving these problems is cakewalk, because if you can do the previous example, we can do this easily. So I'm going to find angle P. All right, I want to actually know how big is angle P. Is it 30 degrees, or it's not 30, but is it 27, is it 55, whatever? There's a mess there. So I'm going to set it up as if I were solving for one of the sides. Okay? Brian, what function do you want to use? There's no wrong answer. Sine, cosine, or tangent, which one flips your trigger?
Sine.
Sine. Okay. So the sine of angle P is equal to what, Brian?
3.
Over?
4.
No.
5.
5. Opposite over hypotenuse. There's a reason why I left that gap there. You'll see why in a second. I want to get P by itself. I'm taking the sine of P. How do I get rid of the sine? Right. You don't divide by sine. Okay, that's not a viable solution. You can't just divide by sine and cancel it. Just like you wouldn't divide by a plus sign. That's silly. We undo the sign by using the inverse function. Basic rule of algebra, whatever you do to one side of the equation, you have to do to the other side of the equation. What's the inverse sign of the sine of P? P. Just like, what's the square root of 7 squared?
7.
7. Where do you get that value? Inverse sine of 3/5? Calculator. Go, man, go. Go.
36.87.
Can somebody confirm?
Yeah,
I got it.
confirm.
Degrees.
I backflip on.
Okay, now this is where I'm going to violate my previous rule about not using approximate information. We're going to cheat a little bit here and find angle A. What's the easiest way now to find angle A? 90 minus this mess. So on your calculator, just do 90 minus the answer and find out that angle A is 53.13. Okay, that's the one time I'm going to allow you to use approximate information. Because if we went through the whole thing all over again with a trig value, we'd still get 53.13, so I might as well just cut out the middleman. Okay, not so bad, right? Just write the same trig equation, you just have to remember, leave a little space there, and undo that function. If Brian had chosen a different function, if he would have chosen tangent, for instance, our ratio would have been different, but you would have solved it the same way. Okay? Now we can find any missing side, we can find any missing angle, which leads us to the next example, which would be solving a triangle. We did that already. Okay, yep, great. All right, solve the triangle. I've given you 3 chunks of information about a triangle. How many chunks are in a triangle?
6.
6. 3 sides, 3 angles. When it says solve the triangle, it means when you're done, you should have all 6 pieces of information. What do you think the first thing I should do is?
Draw a triangle.
Draw a triangle. Okay, where's the 18 go?
In between A and C.
In between A and C. Where's the 13 go? We'll call that lowercase c. So we need to find angle A, angle B, and side C.
Okay.
Which one do you want to do first? Ben?
Side.
Side C.
Yeah.
There are a couple different ways to find the side C. What's one way?
We could do leg opposite of angle C.
No, I can't use, no, stay away from that 90-degree angle.
Yeah.
Uh-uh.
Leg opposite of angle. Leg adjacent to angle A and the hypotenuse, so you could do cosine A.
There's one small problem with that.
What?
I don't know how big angle A is.
Oh yeah.
Rule number one, or method number 1, you could use Pythagorean theorem. 18 squared plus 13 squared equals c squared. But let's pretend we're not using Pythagorean theorem. That, by the way, is a viable solution because these are given information. This is given information, so that would be a good way to solve C. We're going to solve it using trig. In order to solve that using trig, I need to find one of the angle measures first. Abby, what do you want to find first, A or B? A. Okay, so angle A, if we're looking at this angle, is 13 opposite, adjacent, or hypotenuse?
Opposite.
Abby? Opposite. Is 18 adjacent or hypotenuse? Which function uses opposite and adjacent? Tangent. Okay, so I would get an equation there, Abby. Tangent of angle A is equal to what ratio? Is it 13 over 18 or 18 over 13? Well done. Almost done. How do I get A by itself, Abby?
Oh, you divide that one too.
No, remember, can't divide by the trig. Can't divide by a plus sign.
Inverse of.
You take the inverse tangent of both sides. Okay, punch that into your calculator. Tell me what it is.
35.84.
Say again, I'm sorry.
35.84.
I back a penny on that.
All right, excellent. Now, while that's on your home screen, store it. You know how to do that, right? Hit the store button. Where are you going to store it? Store it into A. Because it's angle A. Pretty clever that way, huh? A is above the... Yeah, okay, got it.
Oh gosh, that's so sick.
And then you do alpha.
Answer, store, alpha, A. Now, whenever you use the letter A on the calculator, it's going to put in the exact answer of 35.85. Not that rounded answer. It's giving you an exact answer. Are we good?
Wait.
Okay. How big's angle B?
Okay.
We.
John? Stow. It's on the left-hand side. Then, assuming you have the number on the screen, right?
Yeah.
Hit stow. It should say answer arrow. And then A you get to by going alpha, which is the big green button. And then find A. I don't know, may I?
Math.
Like I can see this, I don't have my, I can't, whatever, okay. It's a blur to me, I can't see it on my glasses. Okay, got it?
B equals 54.16.
We good with that?
9.
How'd you find that?
90 minus A.
Yeah, 90 minus A.
Oh, right.
Now we have 5 of the 6 things. The last thing we need to do is find C. And we could have found C by using Pythagorean theorem, but we're going to find it using trig. Do you want to use, well, I'm not going to ask that question. I'm going to tell you. We're going to use angle A, because we know what angle A is. And I'm going to use, I don't know, let's use the cosine. So the cosine of angle A is equal to 18 over C. Does everybody see how I set that up? Okay. I know what A is because you stored it in your calculator. My variable is in the denominator. This is where I do the switcheroo. So C is equal to 18 divided by the cosine of A. Your calculator is smart enough to know that if you literally type this in, 18 divided by the cosine of A, it'll give you the answer because it knows what A is. You stored it there. Yeah?
I'm just wondering, so like the cosine is equal.
Wait,
like,
hold on. If it's a philosophical
like-
question, let me finish the problem.
Got it.
Because you can take us on a tangent that I'm not ready for.
Huh.
Okay.
Got it? Say ha?
Because he said tangent.
Oh. I didn't even plan that. That was pretty good though. I gotta remember that for next year. What's C?
22.2.
22.2.
Are we happy about that answer?
Yeah.
Yes.
Well, let's see.
Yes.
Not a pun also. Thought you'd catch that one. 22.2 is the longest side. C is the biggest angle. B is the second biggest angle. 18 is the second biggest side. A is the smallest angle. A is the smallest side. So we're good to go. Okay? Initially, you'll get confused as you work through this. You'll forget how to store things. You'll forget, did I put that into A or into B? You've got 26 places to store it. Store it in the one that matches what you're solving for. Question, Cassie?
If you do it and then like it doesn't make sense with like the smallest angle and small side and something like that, does that mean you get it wrong?
Yes. Most commonly, when people make mistakes, they make the mistake doing one simple thing. They use the wrong trig function. They do sine as adjacent over hypotenuse, so they use the sine when they should have used the cosine. Okay? How are we doing so far?
Good.
All right. Got a couple more examples for you,
Are we gonna get our quizzes back?
if we have time.
Alright.
Told you.
All right, let's do a word problem. You try this one on your own. Draw a picture, set up your triangle, solve the problem. There are a couple things we're going to assume again. We're going to assume that the flagpole is perpendicular to the ground. We're going to assume that it's on level ground. And we're going to assume that you don't have one leg shorter than the other.
The angle up
From your eye. Some of you look thoroughly confused. Do you want help with the picture?
Yeah.
A couple of you look like you're going to throw up. Ground.
I guess.
Flagpole.
Oh, I see. We're not even doing this.
America.
49.50.
Okay.
You've lost some weight. 5.5?
Oh my.
Oh, that's the road.
X. How long is this?
5.5.
5.5. Solve for X. Oh wait, we missed one chunk of information. Hundo. Solve for X. Your final answer should be X plus 5.5 because your eyeball is 5.5 feet off the ground. Unless you just put your eye down on the grass and look at it. Which would be pretty gross. What function are you using? The tangent?
The tangent.
Yeah.
That's great, thank you. Opposite side is what we're looking for. We know the adjacent side. We don't care about the hypotenuse. Set up the tangent. Oh, I forgot this too. 37.5 degrees. That's kind of important. As always, when you're done, ask yourself, does this make sense? And that flagpole is probably not 6 feet tall. It's also probably not 1,400 feet tall. You have an answer?
A question.
Yes?
So it would the equation would be tangent 37.5 equals x over 100.
You got it. Got an answer? Hold on. Give everybody a chance. Check with your neighbors, see if they got the same answer.
Okay.
Yeah.
Switch left out and then add.
For how tall?
Oh, for how tall?
That's kind of the question, but.
I'll just
Yeah, but you need to
do it the hard way. Whatever. Gotcha. That's all that matters.
How much is Spanish left?
Not
The
much.
figures are up there. That's what you got?
Adding like one.
What's x equal, Nolan?
76.73.
76.73? Or is that the final answer?
No, that's what x
That's
is.
before you add.
76.73. So the answer to the question would be
82.23
units?
feet.
Feet. Is that reasonable for the height of a flagpole?
Yes.
That's about 8 stories. It's probably a little big, but it's like one of those giant flagpoles you see outside gas stations where they got the monstrous flags on them.
Wait, can you keep that up?
Sure. Good?
It's not.
Day 5 tonight. We'll start with the quizzes tomorrow. Bingo! Nailed it. Have a great day, everybody.